Okay, here's our path. First, how light behaves. Then, how we put it to work, the tools we need, and finally, sending data at light speed.
All right, let's start with the basics. What actually happens when a beam of light hits something?
If light hits a mirror, it just reflects. Super predictable. The angle in always equals the angle out.
But if light passes through something new, like from air to water, it bends, and that's called refraction. Now, here's where it gets really cool. At just the right angle, the light gets trapped inside. This is the key.
And this one, simple principle, it's literally what makes modern fiber optics possible. It's all just trapped light. So we can trap light. Now, how do we turn that into something powerful? Let's put that light to work. So far, we've pictured light as a simple array, but to really control it, we have to think of it as a wave. This is a waveguide. See, it uses that same internal reflection to keep the light wave trapped and guided along a path.
Okay, so we can guide light now, but we need to create it, boost it, and encode data on it. That requires a toolkit.
Everything starts with a source. Laser diodes are tiny devices that generate that first, precise beam of light. As the signal travels, it fades. Optical amplifiers act like booster stations to keep that light signal strong. So, how do we get data onto the light? That's the modulator's job. It imprints info by flicking the light on and off. And here's how. An electrical voltage basically controls the light's power, creating that pattern of ones and zeros.
So we have a source, a way to boost it, and a way to encode data. Let's put it all together now.
And here's what it looks like all together. This is a complete photonic communication system, from sender to receiver. It really just breaks down into 3 stages: a sender, the transmission line, and finally a receiver. And get this, it's not just for sending data. The same exact tech is used for storing it, like on DVDs. Here, a laser reads tiny pits on the disk's surface. It can even focus through different layers to read more data. So from a simple reflection to a global network, we've seen how powerful photonics is. What's next? Computers that think with light.